understandable
Mhm.
for you. So number 2 here,
Mhm.
what I'm going to also do here is just snip the equation. We'll come back to the answer space. So question 2 here, it gives you this thing right here, and it says to solve. So on the left here, the left is what's called a perfect square trinomial. Have you seen that or heard of that?
Yes,
Okay, and here's how I know. Here's how I know. So what is the square root of x squared?
it's X
X. And what is the square root of 100?
10.
It's 10. Now when I merge these together, when I multiply these together, I get 10x. And then if you double it, I know it's another step there. If you double it, you get 20x. And do you see that 20x is right there?
Yeah.
Okay, so if you can identify that something is a perfect square trinomial, okay, and there are two forms, and I'm doing a bit of teaching here, but there are two forms. There is a squared plus 2ab plus b squared. This always becomes a plus b squared. So notice there's a plus and a plus, okay? And then the other one is a squared minus 2ab plus b squared. It always becomes a minus b squared. So this needs to go in your memory bank. This needs to go onto a reference sheet, something to help you remember. So why do you need to know all that? So to do this problem, you first have to recognize, okay, it's a perfect square trinomial. So let's just say you're in agreement with everything I just said. Okay, and I'll show the formulas here. Your a in this case, your a is x, and your b is 10. So here your a is x and your b is 10. Do you see that? Because 10 squared is 100.
Yeah.
So just the left side, we're going to deal with the right side. Just the left side becomes, I don't even know where to put it, becomes a plus b squared, which is x plus 10 squared.
Oh, okay. So now that was what I got confused with. They would take these problems and then they would put it in the x equals something, and I couldn't figure out why they picked that number.
Yes.
I tried my hardest and I couldn't figure it out.
Yeah. So if we're going to do a couple of these, but just like if you're okay to this step here, the way you solve this here is using the square root property. And what that means is you're going to take the square root of both sides. You're going to take the square root of x plus 10 squared equals plus or minus the square root of 36. Okay,
Right.
so on the left side, it's x plus 10. On the right side, it's plus or minus 6. And then you subtract 10 from both sides. So x equals minus 10 plus or minus 6. And what that means, there's really two things. It's minus 10 plus 6, minus 10 minus 6. Is that okay?
Yeah, I've seen that where it's either it's a plus or minus whatever number you get by squaring
Yes.
the equal number. Yeah.
Okay, so our final answers are minus 4 and minus 16. Let me know when you've gotten all this down, and I'll go back up and we'll look at the actual answers. Do you have all this down?
Yeah.
Okay, so if we go back to the answers, looks like answer A is correct. Okay, so let's do number 6. Number 6, actually that one is the same. All right, we will do number we will do number 1 next. Okay, so number 1, it says solve for x, just like we did in the previous problem. And the way you figure out if it's a perfect square trinomial, PST, short for perfect square trinomial, is you take the square root of x squared, the square root of the first term, Then you take the square root of the 25, the last term, and that's 5. You squeeze them together, you're multiplying. Then you double it. And if that is the positive or negative of that right there, it works. So this one is.
Yeah.
So this one's in the form a squared minus 2ab plus b squared. And once you recognize it's a perfect square trinomial, okay, a is x and b is 25.
Right.
Okay, so now this right here becomes a minus b squared. So you're going to write x minus, I'm sorry, b is not 25, b is 5, because 5 squared is 25. You write
Right.
x minus 5 squared equals 35. Okay, so now we take a square root of both sides. So you get x minus 5 equals plus or minus the square root of 35. So this time the square root of 35 is not a known value. It's not friendly. And what I mean by that is it doesn't reduce. So you just leave it.
Oh, okay.
Okay, and then you add 5 to both sides. Okay, so you're going to add 5 to the left, add 5 to the right. So x equals 5 plus or minus the square root of 35. And that's really two things. It's 5 plus the square root of 35, and it's 5 minus the square root of 35.
Okay.
I think the correct answer is so this time it's actually written as this line right here. So it looks like it's B.
Okay.
Is that okay?
Yeah.
All right. So let's look at 3. So again, we're gonna focus our attention over here on the right. And if it's a perfect square trinomial, then you have the square root of x squared, that's x. The square root of 1, that's 1. So it's always this first and this third. And when you merge those together, you get 1x, and then you double it, 2x. And so this one's plus plus. So this is a squared plus 2ab plus b squared. And you just got to figure out a and b. You got to figure out what number squared gives you x squared, which is x. What number squared gives you 1, which is 1.
Right.
So you have to be able to do this. You have to be able to identify this. And this becomes a plus b squared. So you write x plus 1 squared equals 17. So from here we can solve it using the same approach that we did in the previous problem. We can take the square root of both sides. So on the left, it just becomes x plus 1. The square root of 17 is not friendly. It's not known. So we just leave it. It's not possible to reduce. And then you subtract 1 from both sides. So x equals minus 1 plus or minus the square root of 17.
Okay, that makes sense.
Okay, so let me see. So those are the perfect square trinomials. Let's go do number 5 because it's related. And then we'll move on to like a new grouping of questions here. So this problem says, it says x squared plus 1x plus fill in the blank. And they want it to be a perfect square trinomial.
Right.
Okay. So you know that you first take the square root of x squared. We've done that a bunch.
Mhm.
But then you also have to take the square root of whatever's in that sort of placeholder there, that bucket. And these are the possible options. So which one do you want us to try first? We're going to just guess and check this one.
1/4.
1/4. Okay. So the square root of 1/4, if you haven't done this in a while, it means the square root of 1 over the square root of 4. What is
Yeah.
that? What does that equal?
1/2.
1/2. And then I said, okay, you take the result of that and you multiply these together. So you get 1/2 x. But then what's the next step?
Oh, you times it by 2.
Times it by 2, and that equals 1x. And that's what we wanted.
All right. So we're trying to get. Okay.
Yes. Yes. So it's a great question, but when they give you the answers, sometimes you just guess and check. So, all right. Look in here, plus 96 gets this 113. All right. All right. So the next grouping of questions that we're going to do,
Mhm.
I'm going to start with 4. So at first glance, you might think, hey, Matthew, this looks exactly the same like the previous problem. Okay,
Right.
because there's a number and a number. The problem
Mhm.
is this is not a perfect square trinomial because the square root of 12 doesn't equal anything friendly. If it were 25, we'd be in good shape. So
Right.
this is not a perfect square trinomial. So when you're solving problems like this, there's all these different strategies, and I don't know where this one fits in, but let's just say like you recognize whether it's a perfect square trinomial, and then if it doesn't work, you move on to another strategy.
Mhm.
So the more general strategy here is to move everything to one side of the equation.
Okay.
So move left. So that gives you x squared plus 10x minus 24 equals 0. Okay. And this is called factoring a equals 1.
Oh yeah. Yeah, I've seen that.
Okay. So we're looking for two numbers that multiply to negative 24. Okay. But they have to add up to positive 10.
Right.
So for example, it could be negative 1 and 24 or 1 and 24, but I'm sorry, 1 and negative 24, but those do not add up to positive 10.
No.
It could be negative 2 and 12 or 2 and negative 12. The reason I have to show both of these is because it's negative 24. This last one is negative, and either one could be negative, but not both.
Right.
Negative 3 and 8, 3 and negative 8,
Mhm.
running out of room here. Negative 4 and 6, 4 and negative 6. Do any of those work?
Well, don't all of those work?
They have, one of them adds up to positive 10.
Oh,
So yes, to answer you, yes, they multiply to negative 24, but which one adds up to positive 10?
-4 and 6, or 4 and -6.
Okay, I'm gonna show you what you just told me, and you can see that those don't work. So let's try another.
Yeah, I'm sorry.
I mean, they do if they're both positive, right?
Right. So the -2 and 12 and 12 and -12. What? Sorry, the 2 and the 12.
Yes, but which one, right? Because
Yeah.
negative 2 plus 12 and 2 plus negative 12, they add up to two different numbers. Which one is it?
-2 plus 12.
Yes, so that becomes x minus 2, x plus 12 equals 0.
Oh, okay.
Okay, so once you factored it, this is the factoring step, you set both factors equal to 0. X minus 2 equal to 0, x plus 12 equal to 0.
Okay.
Then you add 2, x equals 2. Subtract 12, x equals minus 12.
Right. So we just kind of switched our signs pretty much.
You do. Now there's more complicated problems, so it's always good to just follow the steps of solving a one-step
Yeah.
equation by adding and subtracting, but you're exactly right. It does do that. Let me know when you get all this down and we'll move on to number 6, which is a similar question.
Okay. Got all of that.
Okay, so let's look at number 6.
Uh-huh.
All right, solve for x in the equation. So this one has the appearance of being a perfect square trinomial, but it's not a perfect square trinomial. You might say, well, okay, Matthew, it's the square root of x squared, which is x.
Uh-huh.
But then see how this goes with the 4. The
Yeah.
square root of -4. This is, I mean, it's not friendly again. It's not
Okay.
2 because it's -4. If it were just 4, be good. So this is not a perfect square trinomial, but it looks like one, has the appearance of one.
That's why you always check.
That's why you got to check. So now subtract 8 from both sides, because the general strategy, once you know it's not a perfect square trinomial, is to move everything to one side of the equation. So just like in the previous problem now, we have to find two numbers that multiply to -12, but add up to +4. Will you give that a try, please, and see if you can come up with them? How are you doing on this one?
I'm sorry, I'm still trying to think of all the different ways it can be between.
Yeah, so I've got this divisibility, the rule sheet, but I wish I had something else here to help with this, but I've just got the list here. Do any of these add up to +4? See how those add up to +4?
Oh, yes, I do.
Yeah, so this becomes x minus 2, x plus 6 equals 0. So I do have a factoring worksheet on my website. Let me really quickly show you where that is, and then I will also put a link to it in the email I send you.
Mhm.
You will benefit a lot from doing this, and it's organized in such a way that it's like really perfectly designed for you to be able to do this. Now it's in Algebra 1, but don't take too much away from that. That's just me kind of saying where I think it is. If it's right here, it's
Mhm.
organized by type, meaning like you get the same type of problem over and over again. And so when you feel like you've got it down, then you move to the next type.
Right.
So I'll throw that in the email, but let's get back to what you want to work on today and carry on here. So once you've got each of these factors, you set each factor equal to 0. So you get x minus 2 equals 0, x plus 6 equals 0, x equals 2, x equals minus 6.
Right.
And there you go. You're done. All right, so we're going to look at number 7 next, and then the last 3, 8, 9, and 10 are all of the same type. Okay, so this problem here, when you only have 2 terms, it's very possible that it's what's called a difference of squares. There is only a difference of squares. There's not a sum of squares. And what I mean by that is this is of the form a squared minus b squared.
Right.
So when it's in this form, we know how to factor. Like it's got a known formula for it. It's a minus b, a plus b. So all you have to do is figure out, well, what is a and what is b? So notice the minus is here. The minus means you're really just looking at the 4. So
Mhm.
what squared gets you to 4?
2.
And x squared gets you to x squared.
Yeah.
So now all you have to do is substitute these numbers into the equation here. It's x minus 2, that's a minus b, x plus 2, a plus b.
Okay. And then we just FOIL, right?
No, that would be going backwards. That would be going
Okay.
backwards. You set them equal to 0.
Oh, great. Sorry. X equals minus 2. X equals 20.
So x equals 2 and x equals -2.
Mhm.
There you go.
Okay. That makes sense.
Okay, so how are you doing like math on a Friday? Like not exciting. Are you doing okay here? Do you need a short break? Even if it's just a minute?
No, I'm fine. I just
Okay.
need to get a really good night's sleep, so I'm just a little tired. That's all.
Yeah, and I'm not picking up on anything like that. I'm just sort of like, these are not interesting. It's like, so I'm sorry, just the way it is. All right, so we're doing 10, and there's a reason we're doing 10 first. But we'll get, I think we've done all of them except for 8, 9, and 10. And these are
Yeah.
all of the same type. They're all using what is called the quadratic formula, I believe. So we'll take a look here.
Mhm.
So this is not a perfect square trinomial. Really, your focus needs to be on this last number because it's not a perfect square.
Mhm.
And that tells you, okay, well, maybe I can try that technique that Matthew mentioned, but 59 is actually a prime number. So that technique I showed you doesn't work.
Okay.
So it's
there's
like,
a
okay,
prime
didn't,
number, it doesn't work. Got it.
well, not always, not always, not. So
No, not always.
yeah, it unfortunately, yeah. So method one didn't work, method two didn't work. So the next one is the quadratic formula. Quadratic, I need to actually write
That's
that.
the one where you do b divided by 2 times, I mean,
Yes.
squared.
Yes. So the first thing I need to point out to you is that this equation is in this form.
Right.
And you need to be able to tell me what A is, what B is, and what C is. And it takes the sign. So A is 1 because there's really a 1 out front. B is -12 and C is 59.
Okay.
And then yes, so the formula is minus B plus or minus the square root of B squared minus 4AC all over 2A. And this is not great. I mean, this is like there's no, and I'm just going to substitute the numbers here. This is really it's a long formula. You do have to remember it, and depending on the size of the numbers, the answer could be easy or hard to work with.
Wow, that's a lot to work through.
Yes, yes. Now I don't like when students use calculators, but I understand if you want to use one. What you want to use it for is what's inside here.
Yeah.
So you want to know that, okay, that's 144 minus 4 times 59. You know, if you're uncomfortable with that, you know, understand, grab a calculator. We want to get the right answer. It's 236 square root 12 plus or minus over 2. So 144 minus 236 is negative 92.
Mhm.
So this becomes 12 plus or minus the square root of negative 92 all over 2.
Okay. And we don't leave it like that, even though
No,
it's
and
totally
you
good.
notice none of the answers are there like that. So
Yeah.
here's what we have to kind of come off to the side and figure out, well, what is the square root of negative 92? And
Okay.
from a previous lesson, we know it's the square root of -1 times 92.
Mhm.
Square root of -1 times square root of 92. What is the square root of -1?
It's 1.
Nope.
Why is it not there?
I. Yes.
Yes. Sorry, we're bringing back in
No
imaginary
problem. So
movies.
there's a lot of synthesis going on here. There's a lot of, hey, do you remember this? Remember that? And I understand it's not great to be able to have to recall this, especially on a Friday. So this is not, oh, it is looking good. I was looking at the wrong problem. So for each pair,
Mhm.
you can bring out so there's a 2 you can bring out. So the square root of negative 92 becomes 2I square root 23. So you
Okay.
substitute that back in here, 2I square root 23. Now divided by 2 means you separate them. So it's
Mhm.
6 plus or minus 2 divided by 2 is 1, I square root 23.
Oh, okay. And we leave it as an I. We don't try to, because
Nope.
I'm doing work, right?
No, because I is simplified, but I squared is -1. That's when you can
Right.
do something.
Okay. My teacher's doing that weird thing again where the I is on the other side.
Yes, yes.
I don't know why that's how the problem she always shows is like. But yes, okay, that makes sense.
Okay, so 9 is exactly the same. Okay, except it starts out slightly differently, but it's the same problem, meaning we're going to use quadratic formula.
Mhm.
You know, 17 is not a prime number. I'm sorry. 17 is not a perfect square. So it's not a
Right,
perfect square trinomial. Now, when you add 96 to the other side, you get x squared plus 14x plus 113.
right.
And 113 is not a perfect square trinomial either, or
No.
it's not a perfect square either. So you're looking at it, and you know, you say, oh boy, and then 113 is a prime number. So there's no multiple. The reason that matters is because the only two things that multiply to 113 are 1 and 113, and neither of
Okay,
those add up to 14.
right.
So that's what you're left with quadratic formula.
Okay.
So what does A equal, what does B equal, and what does C equal in this problem?
A equals 1.
Okay,
B equals 14.
and C?
And C equals 113.
Perfect. Okay, so now you write out your formula, and you notice I write it out every time. This is probably why I can remember it many years later. That's my technique. Whatever you need to use to remember it, or if you get a reference sheet on an exam, I guess you don't need to remember it. But it would be good to do something to remember this, because it does come back in other math classes, and you may find that you take math again at some point.
Right.
Okay, so it's minus 14 plus or minus the square root of 14 squared minus 4 times 1 times 113 all over 2 times 1. And now it's just a matter of simplifying. It's not great, but 14 squared is 196. 4 times 113 is 452. And you subtract by 252, what is that? 256 minus 256, I think, over 2.
Right.
And then you ask yourself, hey, is the square root of 256, is that a perfect square? What do you say?
Don't believe so.
Okay. So if you're not sure, you always can check with a calculator. I've got a squares and square roots reference sheet on my website. Also send you. It's just a nice list to remind you, because this one actually is. It's the square root of negative 256 is the square root of negative 1 times 256. So it's the square root of negative 1 times the square root of 256, which is 16. What is the square root of negative 1? I. So it actually is a perfect square.
Oh, okay.
And you divide both of these by 2.
Mm-hmm.
So you get negative 7 plus or minus 8i.
Oh, this is like doing long division all over again.
It's not great. Yeah, it's not great. And so just I'll since we may need this one again, I just threw in the chat the link to the squares and square roots reference sheet. The more you look at stuff, I mean, you probably have a great vocabulary because you read all the time. You see a word, and you know exactly how to say it and what it means because you read it in context. And that's all. That's the only idea here is just if you have something out when you're working on math, you may find you scan it and see something there. So we're going to work on the last problem, but I need 30 seconds to take care of something in the kitchen. I will be right back.
Yeah, that's fine.
All right, I am back. We've got one more problem to do, and then we'll have some time to work on some other stuff.
Okay.
Number 8 here. Okay, so number 8 says, it says to use completing the square, and that's where I asked you earlier, like, do you actually have to use the method? But we'll talk here in a moment.
Like we discussed the method, and I like wrote down somewhere in my notes what the method is. It just didn't make much sense to me, so I figured if you use a different way and that makes more sense, then might as well use that one.
Yeah, we'll do some after this question. I'm not even sure it's completing the square. We'll see here. So the first thing we're gonna do is FOIL. We're gonna FOIL x plus 7 times x minus 9, x squared minus 9x plus 7x minus 63 equals 25 equals 25. So this is x squared minus 2x minus 63. Is this thing on the left, and that's the question we're asking ourselves, is this thing on the left a perfect square trinomial? And you probably can see right away 63 is not a perfect square.
No.
So it's not that. So we got to try another method. We subtract 25 from both sides. You get x squared minus 2x minus 88 equals 0. Okay, so this is where it's like, all right, well, what do I do, Matthew? Like, I mean, I see you did all this. They want you to complete the square, and we might as well do that with this problem. So CTS, complete the square. So this is my approach to completing the square. We'll see if you like it. I've got a couple other ways I can show you. So the first thing we're gonna do is we're actually gonna add 88 to the other side of the equation.
Okay.
And we're gonna leave a space. There's a space right there we're leaving. And I'm gonna put another space right there. So when you complete the square, you always move whatever this constant term is to the other side of the equation.
Right.
Okay. So on the left here, there's a number that we can put here to make x squared minus 2x, and then whatever goes here, a perfect square trinomial.
Mm-hmm.
Okay, and the number that goes here is b divided by 2 squared.
Okay.
And I don't know if you like formulas or not, but that is literally what goes there.
Mm-hmm.
So b is -2 in this problem. So when you cut it in half and then square it, what goes here? I'm sorry?
Because you -2 divided by 2
It's
equals
negative 1. And then you square -1. That means -1 times -1
is just 1.
1, perfect. So this is +1.
Okay.
Now, to be fair, you add 1 to both sides.
Okay.
It's a
Yeah.
balancing thing. Like
Mhm.
if you get something, and I don't know if you have any brothers or sisters, but they get something, that's a fairness thing.
Yep. I have 2 brothers. Totally
Yeah.
know what we're talking about.
So it works until there's punishments that are doled out, then you let them have it all. Okay, so now here, so now I'm going to just rewrite this.
Mhm.
X squared minus 2x plus 1 equals 89. On the left here, is the left a perfect square trinomial? So to answer that, let's take the square root of x squared, and let's take the square root of 1
Mhm.
and squeeze them together, and then double it.
So it is.
It is. So it becomes a minus b squared. Your a is x, your b is 1. So this line right here becomes x minus 1 squared equals 89.
Okay. And then we square root both sides, right?
Exactly, exactly. See, this becomes x minus 1 equals plus or minus the square root of 89. And then we add 1 to both sides. So x
Mhm.
equals 1 plus or minus the square root of 89.
Okay.
So if you understood all that, you're doing great.
Mhm. I did understand how you did all that.
Excellent. All right, so we've got some time left here, and if you want my opinion is that we spend some time on factoring
Okay.
rather than completing the square, but we could do some completing the square. But it looks like it might show up in another lesson or not at all, like you may be done with it. So that's why I would prefer that. But you're the customer, you get to decide, what would you like us to work on?
I will do factoring. It does seem like something that keeps on appearing in math, so I might as well get it down.
Sounds good. So let me grab that worksheet I mentioned, and we'll look at some of the problems together.
Okay.
And then you can get a feel for this. So the type that we were doing a bunch of is, and I'm going to grab this here. So the instructions would literally say, and they do, they just say to factor.
Okay.
Okay. And so adding this equals 0 that we were doing today, all that is solving, but you still factor. You factor to solve. Okay. So if you notice this problem right here, it looks just like, and I'm scrolling up here to show you, we did a couple of these right here. Remember this one, x squared plus
Yeah.
4x minus 12, x squared plus 10x minus 24. So you've done a couple of these, but I'll remind you of what the strategy is. The strategy is you need to find two numbers that multiply to minus 15, but add up to positive 2.
Right.
So you always start with 1, because 1 and whatever the number is, that always works.
Mhm.
And then you switch the sign. So this one becomes negative, the other one becomes positive. Okay.
Okay.
So then you say, okay, well, is 15 divisible by 2? Because
No.
2 is the next number. No, because it's odd. But is it divisible by 3? Yes.
Yeah.
Negative 5, and then negative 3 and 5. Then you try 4. 4 doesn't work. And 5 gets you wraps around on this list.
Right.
So what that means is you're done. Like once you wrap around, you're done. So one of these 4 adds up to positive 2. Which one is it?
-3 plus 5. Well,
Yes.
-3 and 5. Sorry.
Yes. So you say x minus 3, x plus 5.
Okay. And then we set them to equal 0, right?
No, well, you could. So we okay. So let me try to be clear. So do you understand? Is this part all clear?
Well, yes and no. I still have a hard time with taking the -15, but I understand how you did it. You do the most obvious, and then you go to the next number. If it's divisible by that, you put the 2.
Yes. Yes.
You keep on
Yes.
going until it wraps around and
Perfect.
and back.
Okay. Great. So let's just say the question said solve instead of factor.
Okay.
What is the difference between this thing in red and this thing in red?
It's set to equal 0.
So solve means you have an equal 0.
Okay.
Now, how do you solve? You factor.
Mm-hmm.
So you factor, like you said, and then you set each factor equal to 0.
Right.
So x plus 5, x minus 3, you set them both equal to 0. So x equals -5, x equals positive 3.
Right.
Okay. So for the following problem, I just want you to factor. We don't have to solve. That's an extra step that's not needed for these problems. But I want you to try this one on your own, please. It is just like the last one, just different numbers. Take a minute, see if you can work this out on your own, and I'll be right back with you.
Okay.
How are you doing on this one?
I'm still factoring out. I'm doing that.
Okay, do you see that it is -2 and 9? That works.
Yes.
So we write x minus 2, x plus 9. Okay, let me have you try one more, please, and we can make this our last question. But I really want you to get this one all the way through on your own. And just to be clear, you can actually stop on this list when you get the ones that work. You don't have to keep going. Like, but don't try to just guess them. It's really good to do it in a way where there's a nice order. You know, like when you read books, you don't. I mean, I hope you don't do this. I don't go to the end and read the last chapter. But if you don't mind, give this one a try. I know you can do it. Take a minute here and see if you can work it out.
Okay.
Let me know when you've got it.
Okay.
Did you get B -5, B plus 10?
Yeah.
Awesome. Hey, great job today. You know, you get a gold star for doing math on Friday. I hope you feel better, and I'll talk to you next time.
Okay. Thank you for the help.
You're welcome. Have a great day. Bye now.